Hello, everyone. So thank you for attending to our bite-sized science session. It's a very informal peer-to-peer sort of learning. We have a lot of expertise across teams. We're trying to share that. Most of the content will eventually go online publicly, so no patient identifiable information, etc. But any and all topics, all the way from software engineering to ML modeling to productionizing, etc., are welcome. If you want to talk or if you have ideas about talk, please let me know. Today, we're very lucky to have Martin, who is our beloved software engineer in AI Center, and he's going to talk about types and Twilight. So over to you, Martin.
Yeah, so I think types is probably a bit of a dry topic, so I threw in a bit of a curveball with the beloved 2008 fantasy film Twilight there, just to try and make things a bit interesting. So you'll see hopefully the relationship there later on. Yeah, thank you so much, Teddy. It's great to be able to speak. I know we're basically in Christmas now, so majority of people are away and drinking eggnog or whatever people do as we speak. So I really appreciate those who've joined live taking the time.
The hardcore type fans.
The hardcore software engineering types fans are here, my exact audience. But for those who are watching online, I believe this is going to be distributed online. That's great. Welcome to you as well, online after the fact, I should say, from the recording. Great, so what I'm going to talk about, as Teddy has kind of alluded to at the AI Center, again, I know lots of people here are from the AI Center, but if you're from outside the AI Center, AI isn't all that we do. It's mostly what we do, but we like to also invest in the ecosystem around AI and doing things well there as well. And one of those areas, alongside things like data engineering, etc., data science, is software engineering. So we like to do software engineering. So I'm going to talk a little bit about something that I think is really important in software engineering that's often overlooked, which is types. So with that prelude, a couple of guest disclaimers. So first of all, the kind of audience for this talk is people with some experience with Python, some knowledge of data types, and you also have to have a little bit of knowledge of the 2008 film Twilight, although that's not a real prerequisite. And with that comes some disclaimers. So I like to think that I do things well. I like to study things and make sure that I'm conveying to you things correctly, but I can't claim to have, for example, a PhD in type theory. Much of this comes from a place of enthusiasm rather than, say, academic, shall we say, rigor. A second disclaimer is that I think there's being a programmer, which is doing things well, and that doesn't always necessarily align with how a language wants you to program. So you might have heard this term Pythonic, which means that Python has a very it has a strong view on how things should be done, and that doesn't always necessarily align with how things are done generally in programming, if that makes sense. So I'm going to tell you some things that if you read the Python guidelines will say, oh, don't do this, don't do this. But I still do, because in my opinion, it's still a good way to write software. However, if you are a Python purist, then there will be things that you see and go, oh, I don't think we should be doing that. So in the end, it's about which kind of school of thought you want to attach yourself to. And a good example of this is are these property decorators, so which some of you will probably see that I don't mention, but are, of course, a big part of Python. Finally, of course, there's probably people on the call or listening and watching afterwards who will know way more than I do about these things. So please feel free to chip in and teach me as well with what you know. Resources, again, I guess just some housekeeping. So all the slides that you're seeing have been compiled from code. So that, I don't know, that's, I guess, like a little meta thing using a technology called LaTeX that you might have heard of. So this is all online. You can find this on GitHub, and all the examples that you'll see and all the slides are all there in text form. So I can version them, which is very cool and very nerdy. And again, this is just like a little sidebar to say that I think LaTeX presentations get a bad rep. They can be quite ugly, but everything you're about to see is in LaTeX. It's all been compiled from code. So we should do more LaTeX. We should do more text-based stuff. It makes our lives a bit more easier. Yeah, and other technologies, of course, are great. Okay. All right, so what am I going to talk about? So I'm going to go through quite a lot, and I know we don't have very long, just because I'm passionate about so many different things, but I've kind of staged the talk so you can kind of mentally kind of disconnect at any point when you feel like you've learned too much. So in the first, I guess, 10 or so, 10, 15 minutes, I'm going to do a quick start. So if you want to use types in Python, how do you do it? And then after that, I'm going to kind of go through a bit of sort of very quick theory, that questions that might result from that quick intro. And then in the middle is probably the densest bit, so you can go and make a coffee then if you want, which is about custom types. And then finally, And I would say if there are other people on the call or people watching who predominantly work with data, and when I'm talking about things like inheritance and polymorphism, are like, oh my goodness, why would I ever do this? I'm not a software engineer. I would say hang on for section 4, because that's where it's going to come right back to why are types important for if I'm just working with data. So yeah, I've put that at the end on purpose to keep people interested. So that's what the content looked like. So let's jump in then with the quick start. So let's start with a little example. So people who have coded in Python or probably any other language have probably done something like this, right? You've got a load of code, you run it, and you want some insight into what it's doing. And we know we should do proper logging, we should use proper debugging tools, but let's be honest, most of it are just going to put a print statement in, right? We're going to put a print statement in with some corny line that's like exclamation mark, you know, so you can pull it out the terminal, and it's going to say at line X, my value is this, right? And then you're going to print out that value. We've all done it. It's not how we should do it, but we've done it, okay? And equally, I'm sure that you've all done it this way, which of course we know is wrong, right? Because we're trying to do something here that we shouldn't. And if we try and compile this, we'll get this error, which again is probably familiar to lots of people. What you really wanted to do, right, was you needed to convert my complex value, which is an integer, into a string, of course, because you can't combine types that are different here. Python won't let you combine types that are different, right? Now, most of the time, this is okay, right? Because when you run this code, this is just a few lines of code. You run it, you see the error, and you're like, oh, okay, goodness, whoops, I forgot to do this. I should have converted this integer to a string first. That's fine. However, what if we do this instead, right? What if instead my sneaky little print statement to work out a complex value actually comes after quite a long, complex and long-running operation? So let's say I'm loading a model into GPU, and it's actually taken quite a bit of time to do it. And then whoops, it actually ends up crashing after doing that, and I have to start the process all over again, right? So in this case, we're less lucky because we actually have to rely on the running code to find our type error. And that's not something that I would argue we should do. So what's the solution? Again, just jumping right in, even if you sort of detach now after these next few slides, hopefully these first 3 slides have been helpful. What I suggest that we do is we install something called a type checker. This is a piece of software that works alongside Python to effectively help you find these little errors before you run your code. So it can statically analyze your code and see, without actually having to run it, what the error is in advance. So what we can do is we can use, I won't get into the sort of preaching about UV, but we can use this new package called UV to manage our dependencies. We can install MyPy, which is a type checker. We can run that type checker against our code, and it will tell us in advance what this problem is. Okay? So if you don't take anything else away from this talk, if from now on you sort of lose interest, I would strongly suggest that you add this to your Python development workflows, right? There's tons of ways to do it. You can do it through the command line like I'm doing here, or you can add it to your IDE, etc. So there's loads of different ways to do this. So this is, I guess, the minimum what I would suggest for today. But however, the type checkers are fallible, right? So let's imagine we have another piece of code here called adder, and it's designed to add 2 numbers together, right? It takes op1, op2, and adds them together. But let's say, for example, someone else has written this code, or I come back to this code a lot later and actually forget what it does, and I actually try and plug 2 strings into it instead, right? And I get AB out. That's not really the behavior that I wanted. But again, there's nothing technically wrong here. And unfortunately, because there's nothing technically wrong, MyPy can't help us, right? If we run MyPy against this file, it will say everything's fine. So what do we do? Well, this is what I would suggest again. So what we can do is we can actually help MyPy out in terms of understanding what we were intending to do. And to do that, we can add what we call type hints. And there's loads of different places we can add type hints. But one place, and the first place I would suggest that we add them, is every time we declare a function, we can add type hints to the parameters. So in this case, what I'm saying is I'm not just accepting a nebulous op1 and op2. I'm specifically saying op1 is an integer, op2 is an integer. And so I'm communicating a lot more about what my code should do. Now, if I run this through MyPy, it's going to complain, right? We have told MyPy, we've communicated to the author, to the tools, this is what my program should do, this is what it should be used, and the problem can be picked up. So again, I'm gradually pushing you towards more and more typey behavior. So please use a type checker. And if you feel like it, when you're programming, even if you're just writing little functions to support data science activities, please do consider typing the parameters of the functions that you write. That's great, but now let's think of another problem scenario, right? So what happens if I've got my parameter type hints? That's great. But now let's see what happens if someone does something a little bit strange with the result. Again, the return value of the function is not quite clear. So let's imagine someone still doesn't quite get what's going on, or again, I forget what's going on here with this function that I might have written a long time ago. And I try and again add a string to the end of the return result, effectively do what we call concatenation. Much like before, there's nothing technically wrong here, right? If I run MyPy against this, it's going to say everything fine. And that's because, again, I need to send some help to the type checker to tell me how to do this, to tell me what to do. And that is in the form of a return type. So hopefully you can see here that I've added a little bit at the end here. So I added my type hints there to my parameters. I then use this arrow syntax and also then say, this is the type of value that's returned from my function. And this is correct, right? Because this is now fully communicating the purpose of what I'm trying to do, which is to write this little function that adds two integers together. And now then, of course, if I run my type checker, it's going to catch my problems and tell me what I've done wrong and save me a ton of time. So that's the quick start. Again, I'm kind of layering it up in terms of my suggestions, in terms of what takes the most time commitment. I think it takes very minimal time commitment to download MyPy and run that against your code. I can strongly recommend that, especially through things like VS Code, where you can now get plugins, I believe, that do this all for you. Again, if you want to write really robust code, I would suggest adding type hints to your parameters and then adding type hints to your return types as well. Again, it's cumbersome, right? So it does take more time, but in the long run, it will save you a lot of time. But ultimately, it's down to you to decide, and as I'll say at the end, it's about a trade-off per use case. And then just a quick note to say that MyPy is now actually quite an old tool. So there are more modern approaches available, but however, MyPy is very established. Any questions so far? If not, I've anticipated some questions. So I'm going to do a very, very brief, technical history lesson in no more than 2 minutes. So I guess a natural question is, why do we even need to do this at all? It kind of feels a bit archaic to be having to communicate this type information. And in many ways, you're right. One of the benefits of Python is that we don't have to really worry about types necessarily. But again, the whole argument of my talk is that we should be worrying about types because we're ultimately leaving it up to Python to guess. And what Python needs to guess and what other languages need to be told is actually what the type of data we're actually storing in memory is. So taking a step back, every time I declare a variable, what I'm really declaring at the very, very lowest level of the machine is a string of zeros and ones at a certain address. And what we need to do, again, as I've said, is we need to communicate more, or the language we're using needs to infer what the actual type of these values is. And why is that? Well, because we often want to do something with these values, right? We want to maybe add them together, subtract them, and multiply them. And for that to be possible, we need to select the right operation. At the very core, we need our processor to use the right operation. And if it doesn't know the type of data that it's dealing with, then it's going to fail and it won't be able to do that. So that's ultimately why we need types. And in more traditional languages, so those of you who are familiar with C, C++, Java, etc., will probably have seen that you have to specify types. And Python came along and actually, to some degree, did away with that. And as again, like I said before, in many ways, that's a good thing. We moved towards something called dynamic typing. But of course, then you're leaving it up to Python to do a lot of guesswork. And once again, as I'm probably going to say many, many times, it's my kind of thesis that we shouldn't always let Python do that guesswork. We need to give it some help, and we give it that help in the form of type hints. Hope that makes sense. Quick 3-minute history lesson. And then kind of what we're on to now. So how do I know which types are available? Probably another natural question. So if I want to, you've listened to Martin's talk, you think, yes, that sounds like a good idea. I want to know more about how I do type hints. Where do we start? How do we know which types to use? Well, there's many, many docs out there. MyPy have them themselves, which will tell you the types of data that you can add. They will tell you the types of little type hints, no pun intended, that you can add to your code. Another good thing to do is if you start being really advanced with types and you want to add types to your variables as well, and you're importing a third-party library, then you can use that library's documentation to tell you about types as well. And this now very nicely leads into my next section, which is you can also define your own types, which at least to me is very Cool. So next section, next part we're going to talk about is custom types. And for those who are waiting, this is where Twilight comes in. Okay. So I'm going to talk about something, a branch or a style of programming called object-oriented programming. And this is a style of programming that's very nice to teach to undergraduates and people of that era, because object-oriented programming is nice because it's effectively about modeling the world. This style of programming is centered around objects, and obviously we are surrounded by objects in the world. When we do data science, we're effectively modeling data objects. When we write code that does functionality for us, we're modeling actions in the world, which are a form of objects. And because we can model objects and objects are around us and basically anything can be an object, that means that we can also model the 2008 fantasy film Twilight. So that's what we're going to do. This is going to be a running example. If you've never seen the film, this will probably all seem very strange. But it's just, I think, a nice example that actually maps quite nicely to some of the concepts that I'm going to talk about. I also unashamedly love this film and the series. So let's jump in. People who've seen Twilight will know what I'm showing here. When vampires in Twilight go into the sun, they sparkle. Yeah, so it gets a lot of mockery, but I think it's you'll see in a minute why this is quite an interesting example. So let's imagine, for whatever reason, I want to model the concept of vampires sparkling in code. How would I do that? Well, what I might do is I might write a little function. I might call it sparkle. I might write a little file called vampire, and I might return from that function the word sparkle, and I'll add some asterisks on just for good measure to make it really seem like the text is sparkling. I might then come along and write another class that imports that function and then prints the result of sparkle. So effectively here, I've got one bit of code calling another bit of code, and now we print sparkle to the terminal. Wonderful, we've now modeled this idea in code that vampires sparkle. So what I'm going to suggest, though, is actually we should do this instead, and you'll see how this relates to type shortly. So what I would suggest, and the way that I write code, is I very actually rarely have these little floating functions. I pretty much all the time wrap my functions in what we call a class. So rather than declaring the function directly, I would write this little bit of code at the top called class vampire, and then I would stick my function underneath that, as you can see from the indentation, within that class. And then what I would do is, rather than just importing the function, is I would do what we call make an object of the class. So I'd create a variable, use this equal sign, and then use this bracket notation to say I'm actually going to make a copy of this class, everything inside it, and store it inside this object, such that I can then reference that variable and call that function and have sparkle in there as well. And because it's now part of a class, because I've said that object orientation is about modeling the world, modeling the objects in the world and what those objects can do, we stop sort of referring to this as a function and start calling it more a method. It's something that we can invoke on a class. And as you can see, the slides have compiled this code, and you can see once again we get sparkle. Okay, so this is the idea of classes, objects, and methods. And you can teach whole courses on this, and I've just told you about it in a minute. But hopefully it's broadly clear what's going on here. And why am I telling you this? Well, from this small example, again, let's imagine we have another file here. I'm going to declare this name and give it the value of string, again, very similar to the type hints that we saw before. This time not applying them to functions or return types, but applying them directly to variables. And you can see I could store the word Edward in here, which is the name of the vampire that we just saw. And you can see very, very similar syntax, right? When I'm making my objects of my class, as we saw in the previous slide, I can provide a type hint too, and I'm actually using the name of the class as a type. So hopefully this shows you that in reality, classes are types. They can be used very, very similar to the way that we use other types in Python. And actually, under the hood, all types in Python are actually classes, but that does muddy the picture a bit, so we won't talk about that too much. And I don't think it's a very nice decision anyway. Okay. So hopefully you can see why I'm talking about classes now, because classes are types. So this presentation is a nice excuse to talk about objects and classes. So why would I want to do this? Why would I want to use a class rather than just importing a function? First of all, and this is, I guess, a point of preference more than anything else, I think direct function imports look gross. I think it's really gross doing import function from file. I just think it looks strange and odd. I don't like it at all. Obviously not a very compelling reason. Perhaps more compelling reason is the free documentation, right? So when you define a class, you are inherently sort of wrapping this in a label, right? You are labeling your functionality, you're grouping functionality together, and it makes for like a nice unit of documentation for what you're doing. And I guess my other reasons for why this is going to sort of contained in the next few slides, right? So I've got a few more slides now on what classes enable, and each of these is sort of a meta reason for why classes are good. Okay, so we're back to Twilight. Those of you who have seen Twilight, particularly the first film, will know that the character of Edward says some very strange things. This is an example of one strange things that he says, which is you better hold on tight, spider monkey. So if you've never seen Twilight, this is currently very weird, I know. However, let's once again return to the idea of modeling the strange things that Edward says as a part of Python, right? For whatever reason you might want to do it, okay? So let's say we again make a file called vampire. We have a method called, or a function saying, say weird phrase, and that's the better to hold on tight, spider monkey. We choose another weird phrase that's a bit more sinister that Edward would say, like this is the skin of a killer Bella. And then we want to have another method that then calls those two functions to basically print a sort of outpouring of weirdness from our character Edward. Hopefully you can see that there's a lot of repetition here, right? So for this to work, I need to have a parameter name here. I have another parameter name here. I have another parameter name here. I need to pass name through. We end up with this really quite complicated and sort of icky passing of variables. How can we fix this? Well, what we can do is we can define something called a constructor. Again, we won't get into the weeds about what this is, but this is effectively a little bit of code that you place at the top of your class. What that lets you do is store variables or variable values inside the class, much the same way that you store methods, so that those values can be accessed later. So you can think of a class as a sort of a little wrapper around variables and around functions that you can then move around and kind of keep contained, which is really nice. So what we do is we call this constructor and then we store within the class the name. And this is really nice because now you see I can completely simplify Edward saying weird things. So rather than having to pass name around, what I can do in my functions now, well, there'll be methods now because they're in a class, is I can just use this self value to reference what's actually stored in my class. So I can say, well, go to the object, find what's called, and I can grab that. So if in case I ever conflate class and object, class is the template, object is when it's actually made into code. So within my object, I can access these values, and it basically simplifies things down. So I had a very practical example of this the other day when we were building some of the Uncle Armor and Genal Armor stuff, where there was lots of variable passing around, and we were able to really simplify that just by wrapping everything in a class, okay? And then just quickly, how do I use this? Well, I would pass the name in, so this name here to vampire links back to this constructor that we saw before, and then it gets stored inside the class, and we can print speak, and then we can see here that Edward is saying all these weird things, and we've modeled our Twilight use case in a nice way. So again, why is this good? So I've argued this a bit already. So it avoids the need to pass these values around, as you can see. So hopefully you can see how this code here is significantly simpler and thus easier to maintain than the secondary code. And also then we start to move to talk about another key object-oriented principle, which is this idea of encapsulation. So what I can do, and what you probably noticed, is this slightly odd syntax where I did self.name and then these two leading underscores. What I was doing there was I was declaring that this value had what we call private scope. I was declaring that this is a value that should only be controlled from within the class and thus from within the object. And what that would mean is if I tried to access that value from the outside, is it would have no effect, or in some languages, it would cause an error. Now, I said at the beginning that there are lots of things I'm going to say that are not considered pure Python. They're not considered a way to do Python. This is one of those. So there's lots of documents and guidance that will say, don't do this double underscore notation because it doesn't really enforce encapsulation, and that's right. But again, I think we should program to broader principles than just what Python says, okay? So this is good, right? Because let's imagine, so again, people who've seen Twilight will know that there is a character, Alice, who I believe is Edward's sister, and she's a lot more normal for a vampire, for a Cullen, than Edward, and she can see the future and stuff. She's very sort of on the ball, etc. But let's say we had some sort of malicious actor who was working with our code and actually wanted to ascribe all the weird things Edward says to Alice. So in a way, they try and hack our code. They make an object of our class. It's called Edward, fine. But then they come along later and they try and use this syntax to change the name to Alice. You will see that because we've protected this variable, because we've put it inside the class and thus inside the object as this protected attribute, we can't do that. So even though someone's tried to change our value when we run the class again, these weird things are still exclusively said by Edward. So they're encapsulated, they're kept secure. The opposite, of course, would be is if we left these values public. So we've got no double underscore here. We're just assigning name, and I'm sure this is probably how lots of Python is done. And what I can actually do now is I can actually mess with this. I can come to my vampire object, which is supposed to represent Edward, and I can actually mess with it, and I can rename Edward to Alice, and suddenly Alice is saying all these embarrassing, cringy things, which we don't want at all. Okay, so this is the principle of encapsulation Twilight style that kind of shows you that, and again, this is all recommendations, increasing kind of in effort, I would say, but I would suggest that if we are using classes, we should be using some form of encapsulation. Even if it's just a single underscore, that's better than no underscores. Yes, Dan, hit me.
But sorry, I might be being really thick, but I thought you said that Python then doesn't enforce the private attribute. So does that, in this code of the previous slide where you've
This one?
Yeah, it does that. Have you done something to make it enforce the private?
What a wonderful question, Dan. Thank you. Yeah.
Can you also tell about single and double underscore?
Of course I can. Of course I can. Dan, yes, a wonderful question from Dan. So what happens when you do double underscore is internally Python rewrites the name of your attribute to be the name of the class, followed by an underscore, followed by the name of the attribute, right? So what I could really do is here I could say vampire dot underscore vampire underscore name, and I could still mess with the value, right? So the reason Python say don't do this is because when you do underscore, you're not really getting true privacy. Someone who's determined enough could go into your code and could manipulate it, is what I'm saying. If they're naive enough to just try the double underscore, it won't work, but they could in effect still get to your variable. So what people in Python say is then there's no point doing the double underscore. It just makes more work for you because someone can get around it anyway. But what I say is that really we should stick to these principles closely. And even if it is technically possible to bypass it, we should be using the double underscore anyway to indicate our intention that this is a private value. And as you've seen, it does mostly stop accidental manipulation of values. Does that answer your question, Dan?
Yeah, I think I have tried to do private values by using a single underscore, which is why mine didn't work. But there we go.
Gotcha. Yeah, so this gives you sort of kind of pseudo encapsulation. So to come to Teddy's question and to what you said, Dan. So yeah, the single underscore is no different to actually accessing the variable directly. It's just literally documentation for your user to say this is designed to not be accessed from the outside, right? It also gives you what we call protected scope, so it's accessible in the subclass. So again, it's all about documentation. So for me, I need to have 3 forms of scope in any language that I use. I want private scope, which is completely private to the class. I want protected scope, which is technically what the single underscore is, which is private to the class and its subclasses, which we'll talk about in a minute. And I need public scope, which I'm going to barely ever use, but I need to have as a differentiator. So yeah, the single underscore is more about communicating to the outside world that this shouldn't be accessed. And it's also used in protected scope as well. Does that make sense to both Dan and Teddy? Yeah. Again, this is not particularly Pythonic, but I'm really keen that we learn, or that not that we learn necessarily, but that I adhere to the wider principles of programming.
So the 3 forms of scope in Python probably public.
So it's not really Python,
right,
so
yeah.
they don't want me to talk about it like this, but it is there, yeah.
But
So
for your use case, public scope we just straight
Correct.
attribute, and protective we single on,
Correct.
or we should just say telling each other rather than
it's A, documentation, and B, design for use in
double is
subclasses.
what you
Double is private, it's not accessible from the subclasses, but not strictly enforced, just by what we call name mangling. Yeah. So in Java, for example, if you make a private variable, you literally can't get to it. Like it's completely encapsulated. And I need that in my languages personally. This is why it's getting more and more niche. So feel free to make your own decisions. Okay, I hope that makes sense. As always, please sanity check anything that I say, and if you find that I've said something untoward, please let me know, and we can discuss. So the kind of final bit, I think, final-ish bit around the kind of objects and classes before I get to more of the data stuff is something that's also quite neat, which is I've said that objects are basically wrappers around methods and attributes, and I've said that we can use types as parameter type hints. And does that mean that we can pass objects to parameters? Yes, that's absolute. Objects to methods. Yes, that absolutely we can. And so here's an example. It's getting a little bit more complicated, so apologies. Please do feel free to review the examples online. But you'll see here that I've added a method to vampire called fight, and somewhat mind-bendingly, the fight, an object of vampire, the fight method can accept another object of vampire. So what we're effectively doing is passing objects into objects. And that's kind of cool for modeling things like fight, because you've got a vampire fighting a vampire. It's a neat way to represent it. And there's kind of more general use cases that I'll mention in a moment. A couple of observations here. We can bypass encapsulation on the same type. So, and that's again, that's something that Java does really nicely. So encapsulation only makes sense outside the class. So if I'm calling an object of the same class, it's fine to be able to get past encapsulation. And secondly, we can see here that I'm using an int as a Boolean value, which can be really dangerous. So be careful, because obviously 0 equals false, 1 equals true. I've tripped up many, many times for this. So this is a little bit of a shortcut.
Sorry, can you repeat that again? So you're using Booleans.
Yeah, so I'm saying if the value returned from a random number of 0 or 1 is false, I'm going to do one thing. If it's true, I'm going to do another, and I'm relying on 0 equaling false and 1 equaling true, which is dangerous.
Yeah, it's
because
falsy.
Exactly. So if you were, for example, testing your I've many times I've done if variable, right?
Yeah, it's true. It's a more
And if I'm testing numeric values in that if statement, or testing numeric values in that variable, then whether it's false, whether it's 0, can really throw things off. Because they have the same logical value. I don't want to go into that too much, because it's a whole thing in itself.
And the better way to be is true. Is
correct.
False,
the better way would be to do a little bit more than this to make sure I'm truly using true rather than say accidentally using 0. If that makes sense. Okay, but the kind of wider point here is I can pass objects into objects, and that's really nice because then I can make an object of Edward. I can make now a proper object of Alice. I can pass the two into each other. And I can call this method fight, and I can see that there's a fight going on there. And as you can see, these slides are compiled, so the winner there is selected at random. Whether Alice would actually win against Edward remains to be seen. Okay. And this sort of leads me nicely into, I think, again, I promised now one of the final sections on object-oriented design, which is this idea of we're going to talk about superclasses. So let's say we wanted to have vampires fight werewolves, which is again is a key part of the Twilight lore. How would we do this? If I wanted to adjust this fight method so it didn't just accept vampires, it accepted werewolves instead, I could remove the type hint. I could do some if statements, check what the type of the object being passed in is, and do something a little bit ugly. But instead, what I would probably suggest in this situation is we make what we call a superclass. So we make a parent class, a parent type, that can then stand for either a vampire or a werewolf. So again, this is about modeling the world. What is it about vampires and werewolves that connects them? What's the connected entity or item or object between them or concept? Well, it's their creatures, right? So you could use 1,000 words here, but I think creature is a good one. So what we do if we're going to try and make things a bit more generalizable, if we're going to try and avoid repetition, is I could create this creature class. And within this creature class, I'm going to put all code that is common to vampires and werewolves. Well, both can fight other creatures. So it's natural that I move the fight class in here. And they're all going to have names as well. Everyone in Twilight's got a name. So I'm going to move in this init method as well. Okay. Then what I do is what we call extend this class. So I know that vampires are types of, again, classes are just types, and that's effectively what I'm communicating here. Vampires are types of creatures. So I write creature in the brackets there. I know werewolves are types of creatures, so I write creature in the bracket there as well. This is what we call inheritance. Why is it called inheritance? Well, for two reasons, I guess for a conceptual reason, as I've already said, because vampires are creatures, this connects them together. And second of all, very practically, that means that any class that inherits from another, so any class that has another class in the brackets of their class definition, will inherit all of the functionality from that class. So now, without vampire actually having a fight method, I've removed it from there. Remember, I've moved everything into creature. And without werewolf having a fight method, I can actually fight those two together, and it will work. I can pass one object of a creature type into vampire or werewolf, and I get this really nice flexibility. Again, for the former Twilight fans, this slide is developed, loaded dynamically, so the winner does change each time. Who knows what team we're on, Edward or Jacob? So again, why is this good? Again, a bit text heavy here, but as I've said, in point 2, we inherit all functionality, which is very nice. And as we've seen with fight, I can anywhere that I'm offering to accept creature. So in fight here, I'm offering to accept creature. I can pass any types of creature, so I can pass vampire and werewolf. And again, this means that I can interact with just one piece of code and reduce repetition. Teddy, you've raised your hand.
Yeah, I just this point when you create the two options, one option is just create creature as a class, right?
Correct.
And then the vampire and werewolf subclasses inherits as a
Correct.
file.
Correct.
What there's also alternative strategy, well, not sort of alternative, where you make an ABC creature, so like a like class factory.
Correct.
When would you do that rather than just have a creature and just
Absolutely great question. So I didn't want to go to ABCs because I know we're getting into the weeds, but
so,
you brought me there, Teddy. So there is a way. So you might think, what if there is no possible way to abstract up functionality, right? What if there are things about vampires and werewolves that they share, but there's no possible way to get a consistent functionality across them? So the way that they speak, maybe. So let's have a speak method, for example. That might contradict what I'm going to say later, but just let's make a self-contained example. What I could do there is, so let's say I can't abstract up the functionality, but I also want to enforce a speak method. So what I could do there is I could actually define my method, but I could leave it empty. And I could say that when you inherit this class, you have to provide some functionality for those methods, so that I can rely on all creatures being able to speak, but you're specializing the functionality to this child class. So that's what Teddy's been saying. So this is what we call an abstract class. So if there's a method that I simply cannot abstract the functionality from, I can make it abstract, and then in the child class, we can enforce through this abstract-based class approach the fact that you need to implement that. But that is, again, a whole talk, and I'm very happy to come back and do part 2 on abstract. Okay. Finally, I keep saying this is the final concept. I promise this is definitely the final concept, and it kind of relates to what Teddy's been saying. So we kind of talked just now about, typically I can abstract up and I can create common functionality. Through abstract base classes, I can make these empty methods that I then make concrete in the subclass. What if I want to customize functionality, right? What if I want to change the way something happens? What if I kind of like having fight as my default behavior, but I still want the flexibility to be able to override that behavior for my individual objects? So there's a wonderful quote from Jacob in one of the Twilight films, I think it's the second or third, where he just randomly calls someone else, another character, a marshmallow. It makes no sense, but whatever. So let's say, and that's kind of a sassy comment, isn't it? So let's say we want to change the way werewolves behave, and rather than them fighting other vampires or whoever they want to fight, other creatures, they instead just say, what a marshmallow. So it's a bit of a contrived example, but you can see. So what I'm doing here is I'm using what we call the exact same method signature. I'm using fight, I'm using the same parameters, it's got the same return type. So what I'm doing is I'm effectively what we call overriding that definition, that method. And this works because of something called polymorphism, so many forms, which is effectively saying that a parent class can take many forms in the child. And this works. So now if we run vampire, if we create vampire, we create werewolf, and we pass vampire into werewolf, rather than getting a winner, we just get now a response from the werewolf saying, what a marshmallow. Dan, hit me.
Sorry to interrupt.
Please.
So when you said that with inheritance, and you said you've given it it's the same form, so it has the same inputs and the same type hints, but does it have to? Because what if you want to fight to do something totally different in a child class?
Yeah, so let's say there's probably a difference between what actually happens and what Python does. I would suspect if MyPy is good, you have to keep the same type hints, right? But at the very least, you have to have the same name of class. So let's assume you don't have to keep the type hints. I'm pretty sure you do. So let's forget string and let's forget self. If you have, and I appreciate this isn't yet answering your question, sorry. If you want to override the functionality specifically, you have to use the same name of the method and you have to have the same number of params. If you don't have that, if you can't do that, then you have to have a brand new method. The reason is because what you're creating, what we call an external interface. Your parent class is a promise that anything that is a creature will deliver certain functionality. So let's say you were able to completely change how fight operates. You were able to change the number of parameters, you're able to change what it returns, etc. Then code would break, right? Because your consuming classes, your other consuming code, would see the word fight, would see the exact same what we call signature, and would see the same name, sorry, and a slightly different signature, and everything would break, right? You need that. The idea with inheritance is you have this consistent interface which consists of the methods, what they're called, what they take, and what they return. And you can't mess with that. You shouldn't be allowed to change fight to have different returns, different parameters, because it's going to upset consuming classes. I feel like I'm maybe not answering your question, but is there something in there useful, Dan? Sorry.
Yeah, that made a lot of sense. So basically what you're saying is if I wanted to do something else, I should just name it like fight me or something.
Yeah, exactly. If you, yeah, the idea is there should be some promise from the class about what a user can expect from these functions, and that promise is in the form of the name of the method, essentially. So if you want to deviate from that significantly, then you need to change the name of the method, really. Yeah, absolutely. Yeah, another wonderful question. Thank you very much. I hope that makes sense. Okay. I think that's my final heavy sort of throw out there for polymorphism. We see practical use cases in the AI sense. So Joe, not to blow smoke, so to speak, but wrote a wonderful class the other day that had a generic LLM class, a parent LLM class that had some functionality to it. And then we extended it for Anthropic. We extended it for, what else did we extend it for? Gemini. We extended it for local classes. And that was great because then we could have one single function that called that LLM, and it didn't care whether it was calling Anthropic, whether it was calling Gemini. It didn't mind because the functions were consistent and it just did what it did behind the hood.
Like a scikit-learn model.predict.
Exactly. That is a consistent interface that you can change what's going on behind the scenes and it will still work. It's this idea of having a consistent interface, and through object-oriented programming, you achieve this. Okay. Some honorable mentions, which are now not so honorable because Teddy's diligent questioning, but abstract classes or methods. We've talked about that now to extensively. And again, thanks to Dan. These are all positive things, by the way. Thank you for bringing them up. Thanks to Dan, we've talked about interfaces now, which is amazing. Static methods are a bit of a cheat. You probably, if you've used classes, you probably use static methods. This means that you don't have to make an object of the class. You can resort to just using class methods. It does mean you don't get access to state. You can't share values between functions, so you do lose out a little bit. So I would warn against those, maybe except in very specific circumstances. Duck typing, funny name, really like it. I'm not going to go into that, but that's again a concept that you might come across, which is effectively where you don't have to use inheritance, but you can still get some type safety. I think it's a bit ropey. It's a very Pythonic. I mean, it's used elsewhere, but at least through protocols, it's quite a Pythonic thing. But again, something to look at maybe. It's not terrible, but also not great. Just throwing it out there to cover all bases. All right, okay. Final few minutes. So I promised for those who work with data, I would have something very specific, and this is what I'm offering now. Okay, so we're kind of asking the question, where can classes help us? So we've talked about type hints, basic type hints, so strings, ints, lists, etc., as you will see if you look at the docs. And then we've kind of made the argument that classes are type hints, types, as well, so we can use them as type hints. So it's relevant to talk about those as well. And we're kind of now looking at the argument, or making the argument, or asking, where can classes help us? One way is in effectively organizing our code, was basically what I've been talking about for the last 20 minutes, and how that can help us with error reduction, making things more streamlined, etc. So the final thing I want to talk about is somewhere else the classes that can help us, which is in organizing our data. Okay. So I'd warrant that most people on the call, if you work with Python, if you work with data, if you're doing data science stuff, you probably work with JSON. So this is an example of some JSON data that you might find in the world. I've replaced the variables here with what we call metasyntactic variables, which are my favorite thing. You can look them up on Wikipedia, they're quite cool. Basically, if you're ever looking for a keyword, use a metasyntactic variable. It's very computer sciencey. Yeah, let's imagine we've got some JSON here with it's slightly complicated. We've got some keys in green, got some values in red. Some are strings. There's a bit of nesting going on. We've got a nested list as well. If you are working with this data, I would warrant that you've probably done something like this, right? You've probably opened the file. You've probably done JSON.load. You've probably loaded it into a variable. You might have done some type hints. Again, I'm kind of breaking my own rules here by using this any keyword. Ooh. And so apologies for that, but I wanted to stay consistent. Sometimes it's fine, and this is one of those situations where it's okay. But yeah, I'd warrant that you've done JSON.load, and then to interact with your object, let's say you want to get to foobar here at the bottom, you've probably chained together these square bracket calls, right? You've probably said, well, we need to go into bars first, and then we want to get the value of foobar, so I'm going to put the brackets next to each other like this, yeah? Perfectly fine, perfectly fine. Well, kind of not fine, but also fine. Why is it not fine? Well, this has always felt a bit strange to me, I guess, coming from a maybe more typed language background. In that you kind of have to blindly access these resources. So you have to write a string in here and kind of almost hope that it matches the structure of your source data. Yeah. And kind of, I've said it already, but connected to that, using strings as indices, or as indexes, there's sort of a really big room for error here. What if I make a spelling mistake? So the two problems are, what if the structure I'm expecting doesn't match my source data? And then what if I make some mistake with the index that I'm reading in? Types to the rescue. Why, again, is this a type? I guess I would argue that the JSON data that we're dealing with, every time you read in these JSON objects, and the kind of clue is in the name, they are types, right? You're making a new type. And I'm going to sort of mess with language a little bit and call these, just for the sake of this talk, custom data types, because we're reading in a lot of structure, we're reading in a lot of data, or we're going to be reading in a lot of structure and data, but we're doing less with functionality. So unlike traditional classes where I had my things like Fight, I had my things like Sparkle, here we're going to be looking more at the structure of the data that we read in. So I'm going to call them custom data types, but that's probably a better word. So we have this JSON data, we've been treating it quite informally, and I would say that because our JSON data is a type, we should treat it as one. How do we do that? Well, what I would say is every time, almost every time we work with any JSON data that has some level of complexity, we should write a corresponding class structure for that JSON. And to do that, there's many ways to do it. There are some Python native ways to do it. A really nice way to do it is with a library called Pedantic. So you can do your UV add Pedantic and it'll be ready for you to use. And then what you can do is you can import Pedantic like this, and you can start to mirror the structure of the JSON that we've seen. So again, apologies to skip through slides back and forward, but you've seen that we've got this structure. At the top level, we've got foo and baz. So we can replicate that here in the bottom class with foo and baz. We know that baz in itself has some structure, so we can make that another type. Yeah, we can say, well, that in itself is like a nested subtype almost. And again, we can link everything back to what we call base models. So this is this library's pedantic way of saying, this is the type, it's got a certain structure, there are certain rules, and I'm going to, behind the scenes, we've been talking a lot about encapsulation, enforce that for you, so it's very neat. You could use something like data classes instead, which is again Python native, but this gives you a really nice level of validation. So why is this good? Well, now what I can do is I can load in my string as normal, but I can then go through a little bit of extra work. I can unpack that JSON dictionary into key value pairs, which is what this double star does. I can pass it through to foo, which I would import here from my shiny new data type, or my custom data type, I should say. And now, rather than having to, what's going to happen is if my source data doesn't match that structure, I'll get an error. Wonderful. I know that there's a problem somewhere. And second of all, I don't need to do this slightly scary indexing with strings anymore. I can actually just do dot item, and I can get through that. This is really nice. So I've said this already, but if I do this, if there's a problem with the source data, I'm going to get an error. It saves me tons of time in further down the line, having my data not work for some reason. And I have to go back and look at all my sequences of strings and see, oh, actually, I made a type mistake. I made a typo there. And yeah, I get dot notation as well. So I can do dots rather than this sort of sequence of square brackets. And it's nice and it's type checked. And when you do a dot in your IDE, when you do a dot in VS Code, it shows you in the list the actual thing that's coming next in your data. It's really, really nice. Nearly there, which is good timing, I think, Teddy. Is that all right? Nearly bang on. I'll finish in 1 minute. So Python data classes, already talked about it. Pedantic is a little bit more heavyweight. You could use data classes as well. Enums you might have heard of. This is about constraining values as well as the types of values. That's something that you could use on the kind of other side of the type. I know very, very little about polars versus pandas, but I know that you get really nice type checking for polars, things like Pandera and Petito, if I'm saying that right. It's again trying to bring type checking into all parts of the ecosystem. In this case, type checking for data frames, which I work much less on the data science side of things, but I can assume is absolutely wonderful for a data scientist to use. That's all just like 3 final thoughts. So a big theme has been about making code more robust and thus saving time. But of course, adding your type hints, structuring things object-orientedly, although over time it becomes second nature, so it becomes much faster. Over time, that does become it does become a type sync. So you have to sort of trade off over time with the time that you have available for your use cases. You know, if I'm just doing a quick piece of code to turn it around, maybe type hints, maybe objects aren't as appropriate. But if you're doing a longer project, maybe it's worth investing the time in the types in the structure so that ultimately you save yourself time. And then finally, there's lots of other things that I do, that Lawrence does, that Teddy does, that many of us do, that I think we should focus on maybe in this series, maybe generally, that I think it'd be really useful for more people in the wider connections to the AIC to use, or just because it's really interesting, at least to me. I think we should focus on that kind of These things complement types and work with them. So things like unit testing, linting, version control, etc. I think we can develop this sort of tool set as AIC engineers or engineers more widely in the NHS that uses typing, that uses unit testing, that we can then learn about and use regularly. I think that's about 50 minutes, which I think is what we agreed. So thank you so much for listening and for staying. I hope the Twilight thing wasn't too weird. And thank you for there's already been a lot of questions, but if there are more questions, please do shout. Thank you.
Thanks, Martin. That's really good. Please fill the feedback form. Let me know if any other questions out in both inside the feedback form and outside. If anyone want to give a talk. Great, thank you. So I have just a few little questions. The other advantage of doing type-ins properly is also that there are automatic libraries, I can't remember on top of my name, where you can just run at root for a project and it'll create documentation.
Exactly. Yeah. It's
a lot of real libraries use that, you know.
Yes, that's a really good point. Yeah. So the type hints themselves, I would say, are a nice form of documentation. However, absolutely, if you've got these auto doc generations that use the types, then it's more free stuff, right? Nice.
Dan, no.
I like have a data science question, which is that, and you kind of alluded to this in terms of using type hinting for Petito and Pandera on top of polars. But if you like, a lot of what I end up doing is I've got some data frame and then I do a whole load of operations sequentially on the data frame to say, like, it kind of in a sequely way, like you take a thing and then you write a function that changes it and you write another function that changes it and you progressively kind of mutate it. Would you recommend applying that to classes? Because that feels like I'm very used to it looking kind of functional, and most of the people that when I've seen it done, it's quite functional. So and can you kind of explain how that would work?
It's a good point, Dan. I'm going to claim a little bit of ignorance on this. I guess Teddy seems to have some thoughts which I can pass to him, but I think I would agree, absolutely. I mean, typing makes certain assumptions about having a sort of canonical type for a thing. Again, Teddy will probably know more. I don't know too much about how Petito and Pandera operate. I would suspect that maybe there's intermediate types, so you can kind of checkpoint, to use a word wrongly, you can kind of checkpoint your development process where you say, okay, at this point in time, my data should look like X, so I'm going to have it in type X. And then after a few more transformations, I've hit another checkpoint, I'm going to have it in point Y, if that makes sense. If I were approaching data science naively, that's how I would do it. But yeah, absolutely, there needs to be that flexibility. But Teddy, do you know more maybe about how Pandera and Petito
I'm probably a bit, you might want to close your ears. If I'm doing scripting work, which is where I'm just going to get some variable transform in a data frame, throw away, not going to revisit it, I don't bother. I just do like what SQL style transformation, or people who come from R, like tidyverse and continuous pipes. And that's probably good enough for that use case. But if I'm that's my approach, not necessarily the better way or not necessarily the Pythonic way or gold standard way. But if I'm gonna write a more robust code that I'm expecting to use as a pipeline, then I use the design pattern of pipeline. So that's a separate topic of design pattern. So then you can encapsulate each transformation as a class method, and then you can chain it together with the manager to orchestrate.
So it's like one type going in, another type coming out.
Right.
Nice.
So then you know also the errors where exactly in the transformation pipeline the error hits. But in theory, by verifying before things go into the pipeline, you will hopefully minimize having to do that.
So it sounds like, so that was a terrible answer from me, but a wonderful answer from Teddy. Hopefully that's helpful, Dan. Yeah. So I think it sounds like it's accepted that you would have this pipeline approach where at certain relevant stages you would type check where you're at, just to give yourself that sanity check. But no, I think the point is definitely valid, Dan. You know, it's not relevant in all use cases. You don't want to end up in a situation where you're type checking every single transformation, and it just slows you down massively. And also for small use cases.
And similarly to Dan's question, I have problems with, for example, if I'm either inputting or outputting from a function, something like a scikit-learn classifier one, and I do type hinting, but then I kind of broke, because actually that's an easy example, but they're more complex example. Like,
do you mean because of the hints that you need?
Exactly. So that's I don't exactly know what that object is. Same with particularly scikit-learn, at least I know, but tracking face stuff, I don't know what to type in there.
No, absolutely. And I think So I think lots of people won't type hint variables for that, like inline variables, for that exact reason, that it becomes a bit tricky to work out, well, what is
A variable.
what type is torch returning now? Is it even relevant? Should it be encapsulated? I mean, I would argue that I do type hint variables and functions regardless of the library. Like, but that's me being pedantic, no pun intended.
So
like,
do you do for like torch? For example?
Yeah, I will go into torch.
Okay.
And I will find what types they're using, and I will then translate those into my code. Again, maybe it's a bit overkill, but I think that then it gives. Again, it's maybe a bit of a niche argument. I would argue that we should know a bit about what the libraries we're calling are doing, and pulling their types in, I think, is a good way to get that insight. Because it can help you with debugging, right? It's like, oh, well, it throws this error here, and you can say, well, okay, it's because it was supposed to have this, it returned that. Also, it's quite nice in VS Code, if you hover over the method, it'll tell you exactly what it returns. 99% of the time, it'll tell you what it returns, so you just nick it and put it in, and then you get that level of robustness as well. So,
fantastic.
Amazing. Thanks, Dan. That was a really
so that highlight the thing on the things that I don't do, which is going to the library that I'm importing.
Yeah, it's blindly using. I did say that we staged it from very accessible to very niche, and I think it's definitely gone in that order. So,
any other questions, anyone?
Well, there's been lots of questions going on, and I've really appreciated the engagement. I think there was some stuff in the chat as well, which I shall review. I'll see it right now, but I'll have a look. Thank you.
Can you give us a talk about unit testing next?
I can. I might, yeah. Maybe Lawrence and I and whoever else is in the weeds of unit testing can do a joint endeavor. Absolutely, yeah. Unit testing gives you so much security in your code. I love it.
Or test-driven development.
Test-driven development, absolutely, yeah.
All right, guys, fill out the feedback form. Have a very lovely Christmas and the New Year.
Thank you very much
for recording. Thank you.
Thank you for staying.
Bye.
Bye, everyone.